Hello. We want to see how we can use the TI-84 for a function analysis of a parabola. We can examine all sorts of things using the graph part of the TI-84. So first thing we do is that we enter our function. I better clear these entries though. So we'll enter a function here. It should be a quadratic. Let's say it's 2x squared plus plus x minus 1. So enter this. So first you can graph it. It looks something like this. When we want to examine a graph like this, we could try to find all sorts of things. We could try to find the x-axis, the x-intercept and the y-intercept, and the vertex and whatnot. So let's see what we can do. First, I think I would like to make a zoom on this, so I'll get a bit closer. I want to see the area from -2 to, well, 2, I think. So I'll change the Windows settings from -2 to 2, and I'll go to zoom and choose a zoom. I want to zoom fit here. That's entry 0. Means I get a closer look at the parabola here. First I want to find the x-intercepts, and for all this I'll use the calculate menu. So I'll go to calculate, second calculate. The x-intercepts are called zeros here, so that's when the function is 0. So I'll choose 0, and it asks for a left bound. So I would like, if I want the 0 over here, I know it's between -2 and 0, so I'll enter the left bound as -2 and the right bound is 0. So here we go. I'll ignore the guess, just press enter, and it finds a 0 in -1. So one of the x-intercepts would be in the point -1, 0. In the same way, I can find the one over here. So you just have to go in and do the calculate again, add the 0, and now I could put the left bound as 0 and the right bound is 1. Ignore the guess, and in 0.5 there is another 0. Okay, so far so good. If we want to find the y-intercept, that's pretty easy as well, because I know that in the y-intercept the x value is always 0. So what you do is you go to calculate and you choose value, and that means it finds a function value for a given x value. So I'll state that x should be 0, and then it tells me that y is -1. So the y-intercept is 0, -1. Now I also want to find the vertex here. You can see it's somewhere between -1 and the y-axis. So if I want to find that accurately, I go in, calculate again, and I can see that it's a minimum point. So I'll choose number 3, minimum, and I put in boundaries again. Well, it was between -1 and 0. No guessing. So it tells me that in -0.25 there's a minimum, and the minimum value is y equals -1.125. Well, ignore these odd decimals out here. That's due to inaccuracies in the calculator. So the point is actually -0.25. So that's my vertex. And if you can find the vertex, you can also find the axis of symmetry, that would be x equals minus 0.25. So one last thing is, what if we know that y equals 3 or y equals 2, for example? Can we then find the corresponding x values down here? There's a workaround. We cannot do it directly in Calculate, so the workaround is that we insert a horizontal line in 2. We just do it over here, so we go down and we state that y should be 2, and we graph it. So now we have the line y equals 2. So in order to find the corresponding x values down here, we find the intersections of these two. So again, we go to Calculate, and you choose number 5, intersect, and you're asked about the curves. Well, the first curve is actually that one, and the second curve is actually that one. Guess. Well, I know that this lies pretty close to 1, so I can press 1 and enter. So, well, it actually was when x is 1, y is 2. So the intersection here is in 1. So when y is 2, x is 1. In the same way, we can find the other one. So you go to number 5, intersection. My guess is now it's in minus 1. Oh, jeez. Try again. So go to intercept. The curves, sorry. Guess is in minus 1. And the intersection is in minus 1.5. Yep, that's all, folks.